Hi everyone, hope you're having a fantastic Thursday. Um, Hopefully you've had enough time to work on your warm-up, and here is the solution to the warm-up. So for the first system, I went ahead and used elimination, mostly because you had a positive 1y and a negative 1y, so they eliminated really nicely. And I ended up with the ordered pair of 13, comma 6. For the second one, I chose to do substitution because one of the variables, the y variable, was already solved for. Went ahead, plugged it in, and I ended up with 1, comma 1. From there, it asked to find the equation of the line joining their intersections. In order to write the equation of a line, you need two things. You need a slope and you need a y-intercept or a point. So the first thing I did is I went ahead and found the slope. Remember, it's the change in y over the change in x. And then from there, I went ahead and decided to use point slope form. Okay, mostly because one of my ordered pairs was not 0, comma something. So I went ahead and plugged into the point slope form. I used the distributive property, and I ended up getting those fractions. Doing a little calculation. Unfortunately, 7/12 nor 5/12 are nice decimals. They don't terminate in your calculator. So I would like you guys to go ahead and leave those as fractions. All right, if you guys want to look at this a little bit longer, you can go ahead and freeze this. But I want to move on to example number 1 here. By the way, please be prepared to do something along these lines of the warm-up for tomorrow's quiz. You do have a quiz tomorrow. Okay. All right. Let's see here. I'm going to move the screen a little bit. There we go. All right. Our goal for today is going to be to graph an inequality, right? So you have your inequality symbol. Anytime we graph an inequality, there's going to be shading involved on our graph paper. For tonight's homework, I have graph paper provided for you so that you can do it nice and neat and make sure that everything is super accurate on your graph paper. This is really a 3-step process. You guys did this last year. Okay, so I'm just going to give you a little refresher here, and then we're going to go into some more complicated graphs. So the first thing that I want to do, if I want to graph y is less than 3, I'm going to pretend that the inequality is merely an equation. AKA, in my head, I'm saying, what does the line y equals 3 look like? Okay, and if I remember correctly, this is a horizontal line. So I'm going to go on my y-axis to 3 and go ahead and graph that horizontal line. Now, one of the things that you might be noticing right now is that instead of doing a solid line, I'm doing a dashed line. We need to go ahead and determine what that boundary line is going to look like. And if you remember back from Algebra 1, anytime you have merely a less than or a greater than symbol, you'll have a dashed boundary line because it doesn't actually include that line. It's going to be either everything above or everything below. Same thing if we have a less than or equal to or greater than or equal to. Because it's equal to it also, that will actually be a solid boundary line because it will include everything that is also on that line. Okay, and then last but not least, we have to decide which way to shade. My suggestion for doing that would be to go ahead and test any coordinate in the or on the coordinate plane that isn't on that boundary line. So I would not use anything that's like 2, 3 or anything that's 5, 6. I don't want to use our 5, 3. I don't want to use anything that's on that line because that's not going to determine which way I need to shade. So instead, I'm going to go ahead and test my favorite ordered pair, which is 0, 0. So I'm testing this point right here. Okay, I'm going to plug it into my equation. So because the y is equal to 0, I ask myself, is 0 less than 3? If the answer is yes to that, so this is true, then I am going to go ahead and shade towards that point that I tested. If it was false, okay, so if I went ahead and did this and it ended up being a false statement, then I would shade away from that point. Okay, so basically it's a 3-step process. You have to determine what your equation is going to look like. You're going to have to decide what type of boundary line it is, if it's either dashed or solid, and then you're going to have to test a coordinate to determine which way you are going to actually shade. Okay. All right. So We now get to a question that looks something like this. Oh, forgot to fill this in for you guys. Okay. So we want to determine, is it true or false? Does it actually satisfy the equation? All right. So now we come across a graph like this. Some of you guys may know what this graph looks like, and others of you may not. Okay. If you do not know what this graph looks like, my suggestion to you would be to go ahead and grab your graphing calculator. So if you don't already have your graphing calculator out, go ahead and do that. I have a little makeshift graphing calculator over here, and I'm going to go ahead and turn my graphing calculator on. I'm stalling a little bit so you guys can get them out of your backpacks. All right. In the upper left corner, there's a button that says y equals. If you guys go ahead and press that button, you can go ahead and enter in any type of equation. You guys can see I already have this one entered in and then actually cleared out so that we can go ahead and see it again and determine how I did this. So what I'm going to go ahead and do is try to find this absolute values in my calculator. Some of you guys are like looking around on the screen and probably don't see it. There are two places where you can find an absolute value. You can either go alpha window. Okay, so I press the green button and then this window button, and option number 1. Okay, now if you're going to go ahead and type in x minus 4, please be careful. The x that you need to use for this cannot be the x that's, oh, where is it? Down here. Okay, it has to go ahead and be the x that's right next to the alpha button. So I have x minus 4. Okay. Now, just in case you've lent your calculator to somebody else, let's go ahead and do a zoom 6, and that's why we will get a standard graph. Okay, so for those of you who weren't sure, this absolute value graph is actually going to be a V-shaped graph, and our calculators help us see that. Now, some of you guys are like, okay, Miss Jim, and how am I going to get it from this screen over here onto my actual graph paper? Because you know that I'm going to expect nice, correct ordered pairs from you. You have one of two options. You can either go ahead and on your piece of paper make yourself a table of values. So for example, I could go ahead and make myself an XY table here. And I could just start picking some points. So if I plug in, let's say, a negative number. Here I go. I do -4 minus 4. Absolute values are like parentheses, so I'm going to go ahead and do my order of operations inside first, then take my absolute value. So a -4 minus 4 is a -8. The absolute values tell you the distance away from 0, so -8 is 8 units away from 0 on the number line. So I end up with that ordered pair. So one way I could do this is to go to -4, comma 8. I could maybe pick another negative number. -2 minus 4 is a -6. The absolute value is 6. Sorry about that, guys. So I go -2, comma 6. I could try picking 0. I end up with 4, etc., etc. So one way that I could go ahead and do this is to plug in values in making a table. The second way that I can go ahead and do this is by, in my actual graphing calculator, notice in the top right in blue here, it says table. So I could go second table, and I can get the exact same information that I just got. So one of the things that I noticed is that I had an ordered pair of, oh, there it is, -4, comma 8, or -2, comma 6, or 0, comma 4. I could keep going for a while, and I could pull a bunch of ordered pairs from my graphing calculator to accurately graph this. And again, because I know that this is a V-shaped graph, I should know the general shape of this. You can also kind of count here. It looks like 1, 2, 3, 4 is where it's going to go ahead and touch that x-axis, and then it's going to start heading back up again. Okay, so again, your graphing calculator is only there to help you try to find some of the points along the way. So I'm going to graph a few more points on here. Please do the same using your graphing calculator or your table of values. So step 1, I have to go ahead and find the shape of my graph. Step 2, I need to determine what type of boundary line I have. because it is a greater than and not a greater than or equal to, I'm going to go ahead and make a dashed boundary line. So I have dash, 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 dash. And I'm going to make this look like a nice V-shaped graph. Please make sure you get enough points on there so you can see the true shape of that graph. All right, and then last but not least, third step is to determine which way the shading is going to go. So I'm going to go ahead and test a point. Welcome to test any point that is not on that boundary line. I personally am a huge fan of 0, 0, but again, you're welcome to use whatever you would like. So I'm going to plug in the 0 for my x, and I'm going to plug in 0 for my y, and see if this ends up being a true or false statement. So I have 0 is greater than the absolute value of 0 minus 4. My left-hand side is done, so I'm just going to leave that at 0. My right-hand side, I'm going to go ahead and do my 0 minus 4, which is a negative 4. The absolute value of negative 4 or negative 4 is 4 units away from 0. Now, the question that I have is 0 greater than 4? Last time I checked, it wasn't. That is a false statement, so this is not true. Therefore, I do not want to shade on this side. I don't want to shade towards the 0, 0. That would be, by the way, the part that I'm making in blue. I don't want that part, right? Because this was a false statement. I want to go ahead and shade on the other side of my boundary line, aka there is my final answer. Okay, so you're going to want to test points along the way. And again, if you don't know what the shape of the graph is going to look like, you have one of two options. You can either make a table of values, or you can go ahead and use your graphing calculator. And again, one last thing, in your graphing calculator, there are two ways to find that absolute value symbol. Okay, we can go alpha window and pick the first option. Or if you have an older version of the calculator and it doesn't have the new operating system, alpha window actually will not work for you. Your other option is to go second catalog, and it's the very first one on there. So the first one is ABS, and that will also get you your absolute values. But again, that only is necessary if you have the older operating system of this calculator. Okay. All right, so let's go ahead and do this. I am going to go ahead and start a new video in a few seconds here. Why don't you guys try example number 3 with your tables? Okay, I'm going to tell you right now, before you can even go ahead and start graphing all of those lines, please, please, please put everything in slope intercept form so that you can very accurately graph those lines and then determine which way you're going to shade. So again, go ahead and do that with your tables, and I'll be back with you guys in just a little.